Welcome to lesson 9.3. Today we're going to talk about theoretical probability. So theoretical probability is the probability of what should happen based on the number of outcomes that you want to have happen and the number of total outcomes that could happen. So the formula for finding theoretical probability is you take the number of outcomes that you want to have happen and you put it on the top of the fraction, and you put the total number of possible outcomes that could happen on the bottom of our fraction. Okay, so it's number of outcomes that we want to have happen over number of outcomes that could happen. To show finding probability, we use P of and then event. So we're going to use that quite a bit. So if we want to know the probability of rolling a 4 on a die, we would say P of 4. If we wanted to know the probability of choosing red, we would say P of red. So that P stands for probability. So what's the probability of a 4 happening, or what's the probability of red happening? So our first question is, what is the theoretical probability of rolling a normal 6-sided die and getting the number 5? Okay, so outcomes that we want. Okay, there's only one 5 on a normal 6-sided die. Total outcomes, there are 6 total choices I could have, because again, it's a 6-sided die. So the probability of getting a 5 would be the number of outcomes that we want over the total outcomes, which would be 1/6. What is the theoretical probability of rolling a normal 6-sided die and getting a number less than 4? Well, if you remember, if you've ever seen a 6-sided die, you get the numbers 1, 2, 3, 4, 5, or 6. So if we want numbers less than 4, that's these 3 right here. So there are 3 different outcomes that we want to happen over the total of 6 that could happen. So the probability of less than 4, we would say is 3/6. If we can simplify the fraction, we need to. So I can divide the top and the bottom by 3, giving me a probability of 1/2. So half of the time, we're going to roll a number less than 4. Okay, so next we've got the theoretical probability of rolling a normal 6-sided die and getting a number greater than 2. Well, if we're looking at all of the numbers between 1 and 6, the ones that are greater than 2, there's 4 of them. Okay, 3, 4, 5, and 6. All of those are greater than 2. So those are all ones that we want to have happen. And again, the total is 6. So my probability of greater than 2 is going to be the number that we want to have happen of 4 over the total that could happen of 6. So it'd be 4/6. Again, remember to simplify that down. I can take a 2 out of both of these, giving me a probability of 2/3. Now we're still rolling that same die, and we want to know the probability of getting an odd number. So if I look at the numbers 1 through 6, I'm looking for the odd numbers. I've got 1, 3, and 5. So that's how many that we want to have happen. There's 3 of them. Again, for the total, there's 6. So our probability of an odd number being rolled is going to be the number that we want over the total, so 3/6. Again, we have to simplify that down if we can, so I can divide top and bottom by 3, giving me the probability of an odd number being rolled is 1/2. So it doesn't have to be with a die every time. Okay, we could be given this as our sample space here, and we want to know the probability of choosing a triangle. So again, probability is what we want to have happen over the total. So we should probably know the total first. So I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There are 12 total objects to choose from. And for triangle, you'll notice 3 of them are triangles. So the probability of choosing a triangle would be 3 triangles over a total of 12 objects. And again, we want to simplify that down to 1/4. So the probability of choosing a triangle is 1/4. For choosing blue, we need to figure out how many shapes are blue. Well, it's these ones right here, and there's 4 of them. So there's 4 blue over a total of 12. And if I simplify that down, the probability of choosing a blue shape is 1/3. And for the last one, a green circle. If you count how many green circles we have, they're all right here. And there's 5 of them. So the 5 goes on top over the total of 12. and I can't simplify that down, so the probability of a green circle is 5 over 12. So for these next ones, we've got not only colors of pieces, but numbers as well. Okay, so we have to account for both of those. So we have to find the total first. Okay, if you'll notice, if you count all of them up, there are 8 total pieces to choose from. If I want the probability of yellow, I figure out how many yellow squares, or how many yellow pieces there are. Well, there's 2 of them out of the total of 8. So I would say 2 over 8, or 1/4. The probability of choosing yellow is 1/4. For blue, you'll notice I have 3 blue pieces. So 3 over the total of 8. The probability of choosing blue is 3/8. Even numbers. Okay, so I look for all the even numbers. I got 1, 2, 3, 4 even numbers. So 4 evens out of a total of 8. Simplify that down. Probability of choosing even is 1/2. Finally, the probability of an odd number that's in purple. Okay, so any odd numbers that are in purple, there's only one of them right here. So that 1 goes on the top, the total of 8 goes on the bottom. Probability of choosing a purple that's an odd number is 1 out of 8. Go ahead and pause the video and do all 4 of these probabilities on your own. Make sure to find the total first, and then hit play and see how you did. So for probability of blue, you should notice that there are 3 blue spaces over a total of 12. So I'd have 3 over 12, which simplifies down to 1/4. Same thing for green. There are 3 green spaces out of a total of 12, giving me 3 over 12 for a probability, which simplifies down to 1/4. For probability of red, there are 5 red spaces over a total of 12, so my probability is 5/12. And for yellow, there's only 1 yellow space out of a total of 12, so the probability of yellow being spun is 1/12.